So I just want to touch a little bit on graphics cameras versus real cameras. So in real cameras, when we buy lenses for our cameras, they typically have numbers associated with them. Oh, this is a 24 millimeter lens. Oh, this is a 500 millimeter lens, right? And these are related to the telephoto or zoomness of our picture. So is this a control we have in graphics? Yeah, sure. This is in the perspective command. We can set the field of view. So the field of view is this. Thanks to the person who added it into the chat. But yeah, tilt shift lens. That's what those things are called. I couldn't think of it. So here's our regular lens. And here's the examples of the different things. So you've all used cameras where you have zoom like this. Now your phone camera has a concept of optical zoom versus digital zoom. So when we talk about changing the millimeters of the lens, this is typically talking about the optical zoom. The digital zoom is essentially just a cropping that's happening internally. So the effect is quite similar, but the implementation is different in the camera. But anyway, the point being, this is a control that we have in computer graphics. And what would we do with it? What do real photographers do with it? Well, it makes a difference. If I put my camera close with a wide angle, or I put my camera far with a telephoto, it's not exactly the same picture. So here it's been set up where the main foreground figure, the person, is the same size in both of these pictures. However, the background is completely different. So if we set ourselves in one position, our background is going to be, we're going to see less of it. This would be the telephoto picture, right? And if we set the more wide angle, wider field of view picture, then we're going to see more of the background. This is with the camera set in the closer position. So this applies in your computer graphics also. You know, how much of the world do you want to see? Not just of the foreground object you're looking at, but of the background stuff. Depends on which way we want to set a wider or narrower angle. I guess numbers around 60 degrees, 90 degrees are going to be good for the kinds of things that you're setting up, but you can play with it easily. In real cameras, people also worry about the notion of distortion on an object. So particularly comes up for portrait photography. People have a real preference of, do they prefer their face to look like this? Do they prefer this? Do they prefer this? What is the way they prefer their face to look? And so how wide angle we want the lens is going to impact what kinds of pictures it is that we take. Now, what are the other controls on a real camera? So on your phone camera, you don't normally play around with these things, but if you use a DSLR kind of camera, you normally do have these kinds of controls. So aperture exists in a real camera. The aperture is the light comes through in the lens system, and it's not a pinhole camera. So in computer graphics, we have a pinhole camera. We don't have a notion of how big is your aperture because it's always infinitesimally small. It's an exact pinhole. Similarly, shutter speed, we don't really talk about. So when you take a real picture, did you expose for 1/30th of a second? Did you expose for 1 minute? Did you expose for 1/1000th of a second? This notion doesn't exist in computer graphics. Usually our exposure is instantaneously short, unless we're intentionally trying to make motion blur or something like this. So we don't really have this notion of aperture and shutter speed on our computer graphics camera, or rather our aperture is infinitely small and our shutter speed is infinitely short. Now, why don't we have this on real cameras? Because in real cameras, we have to measure real photons. A wider aperture gives us more photons. A longer shutter speed gives us more photons. Since we're all in the fake graphics world, we don't have to worry about that issue. What does that save us from? Saves us from real problems. So this is an aperture, maybe around 11, 8, 11, something like this. This is a f11. This is the numbers photographers would use. Here's an aperture which is too large, and so we get a blurry picture. If you're not a photographer, we'll make it complete sense. But anyway, too large of an aperture gives you a blurry picture. But too small of an aperture, like we use in computer graphics, a pinhole aperture, also gives you a blurry picture, but for a different reason. This blur is coming from geometric optics. This blur is coming from diffraction. And so now you have to go reason in wave optics in order to figure out what's going on to cause this. So in a real camera, we're balancing out these things about real world physics. None of this in graphics.